Will AI discover the origin of life? Here's what Dimas Hassabis, the CEO of DeepMind, says.
I don't see why AI couldn't help with that. Some kind of simulation. It's a bit of a search process through a combinatorial space. Here's like all the chemical soup that you start with, the primordial soup that, maybe was on Earth near these hot vents. Here's some initial conditions. Can you generate something that looks like a cell? So perhaps that would be a next stage after the virtual cell project is, well, how could you actually something like that emerge from the chemical soup?
So will AI discover the origin of life before 2030? I think there's not a bad chance. So to understand that, we're going to first look at AlphaFold, then this upcoming virtual cell project, AlphaCell, and then finally this longer-term hypothetical project, AlphaSoup. Let's dive in. Hey guys, welcome to the channel. My name is Reese. I used to teach tech ethics at MIT, but now I'm teaching this series on how everything evolved, which synthesizes a decade of my research and these 20,000 note cards I've made on all these subjects. So right now we're talking about the origin of life right here. And although humans have been working on the origin of life for almost a century, I think that AI might get there first. So we can understand that by looking at these three different Google projects. The first is AlphaFold 1, 2, and 3, which, from 2018 through 2024. They have this upcoming virtual cell project called AlphaCell. That'll be from 2025 through 2028. Those are my estimates, not theirs. And then AlphaSoup, this hypothetical origin of life project, might be around 2030. So let's look at AlphaFold first. As a reminder, there was AlphaFold 1, 2, and 3. The idea behind AlphaFold, it's the protein folding problem. We're trying to take some primary structure, a polypeptide chain, a bunch of these amino acids, and you fold them kind of like a string of beads, and they fold into some kind of structure. And you're trying to understand what structure they fold into. And so AlphaFold 1 did a pretty good job of these predictions in 2018. AlphaFold 2 did a super good job of these predictions in 2020. And one of the coolest parts of AlphaFold 2 was that it 1000x'd the amount of proteins that we had available to us. So you can see here's this graph, experimental PDB today. That's the protein database. That was humans actually doing, I think, X-ray crystallography to understand these protein structures and also understanding what chain of amino acids make them. And then, AlphaFold 1, it got more than that. It has it has a million structures. But then AlphaFold 2, what they did is they said, okay, we're going to use this new prediction system to create tons and tons of proteins. And so we're going to make 2 million protein structures, and then we're going to open source that and allow the community to use them for drug discovery and things like that. But then earlier, about a year ago, AlphaFold 3 came out in 2024, and it wasn't just the structure of molecules, but it was also the interactions. So that's the crucial idea, is that we now have interactions. And so you can see this example interaction with how the DNA is interacting with this protein, or how these little molecules are interacting with each other. Here's how these ions, this spherical ion interacts. And here's these simple sugars and how they're interacting. And so when you start to look at something like this, you can see that we can not just do structures, but we can starting to see how all of their interactions work as well. And that brings us to the AlphaCell project, which, someone like Dimas calls their virtual cell project. And this is people who are trying to recreate a cell in silico instead of in vivo. Here's a great piece by my friend Elliot Hirschberg about virtual cells. What are these things? And I love, he has this initial version of this in 2012 that shows, here's this little virtual cell, here's the chromosomes, here's the cell growth, they're doing metabolism, they're doing some replication. This is a really cool initial take to try to model a whole cell. Very, very cool. But now people are taking it a lot more seriously. There's the team at CZI, Chan Zuckerberg Initiative, and also the team at ARC. And they are starting to create, they just had a big conference around this about a year ago. And that conference resulted in this paper, How to Build a Virtual Cell with Artificial Intelligence, Priorities and Opportunities. This is about 8 months ago, December 2024. And you can see here's this image that shows, hey, here's a normal physical cell. And what we want to do is we want to create an AI virtual cell through these universal representations of the molecular level, the metabolome, universal representations at the cellular level, and so on. Here's another great image from Elliot that shows some of the work at ARC Institute, which is taking a Tahoe model. This is 100 million different cells, and you perturb them to get a transcriptomic profile, where you start to see that when a cell is having interactions with the environment, what does it start to do? And so we haven't seen the Google version of this yet, but I would bet it's coming in the 4 years at most when we'll see an AlphaCell, kind of a virtual cell project. And then finally, I do think we might see this AlphaSoup sometime soon. Here's a great piece from 2023 from the MIT Technology Review that says, the biggest questions, how did life begin? AI is helping chemists unpick the mysteries around the origins of life and detect signs of it on other worlds. So this piece has dozens of researchers and how they're using machine learning to discover the origins of life. My favorite piece, though, is this one from Lee Cronin, who's the assembly theory guy. And he says, look, Cronin has already spent years digitizing chemistry. He plans to use these systems to conduct experiments in prebiotic chemistry and discover pathways to the formation of life. In analogy to AlphaFold, he wants to make AlphaSoup. And you can also see why people want to use machine learning. It says, the power of machine learning is that it can see patterns in huge data sets when humans can't. You pick up patterns in complex mixtures and pinpoint processes taking place that you can't spot yourself, says Huck. It's such a high-dimensional space that the patterns elude you. You know, humans are good at thinking in 3 dimensions, but it's hard for us to think about these cells that have thousands of genes with their transcriptomic profile, all of these different RNAs, all of these different proteins, all interacting with each other. We can't understand the language of life, but AIs can understand not only the language of humans, but also the language of life. And we're going to use them, hopefully, to understand how life began. The main thing that makes me skeptical that AlphaSoup will happen by 2030, there's no money in it, right? All the money for this stuff is going towards things like drug discovery, or if you can do better drug discovery, you can make an amazing drug and then make lots of money. But if someone finds out the origin of life, no one makes money from that. So maybe AlphaSoup will happen, by 2100. We'll see. Curious to hear what you think in the comments, and thanks as always for listening. Bye. Thank you, as always, for watching, and thank you to Roots donors for supporting this channel. If you want to understand more about the past and how we got here, check out the previous videos here. And if you want to understand the future and where we're going, feel free to subscribe here. Hope to see you then. Bye.